Professor Zawolo. Today again we're going to be going over yet another section of the West African Examination Council Senior Secondary School Mathematics Examination for Liberian schools. Today we're going to be discussing trigonometry, and we're going to be going over finding the sine, cosine, tangent of an angle. We're going to learn how we can find the sine, cosine, tangent of 30, 45, 60 degree angles without a table or a calculator. Sometimes we say we want to find the exact values of the sine, cosine, and tangent of those angles. So because these two angles are equal, you're going to have two sides opposite them to be equal. So if we were to use the Pythagorean theorem, we do 1 squared plus 1 squared, we're going to be able to find that to be square root of 2. So then, how then can we find the sine of a 45 degree angle? Say this angle right here. Let's find the sine of this. So we can say the sine of 45, we know by rule that sine is equal to, sine of an angle A is equal to opposite over hypotenuse. So sine of that 45 degree angle is equal to the opposite. What's the opposite here? 1 over, what's the hypotenuse? 2. So the sine of this 45 degree angle is 1 over square root of 2. But we understand that we cannot leave a mathematical problem with a radical in the denominator. So we have to rationalize. How do we rationalize here? We multiply the numerator and the denominator by this. So when we do this, we're going to have sine of 45 to be equal to square root of 2. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So the sine of any 45 degree angle will be square root of 2 over 2. The other acute angle here, if I did it, I'm going to get the same thing. Now, but that's fine. But this concept can be extended to other angles that are multiples of 45. For example, not including 90, but for example, an angle that is 135 degrees. So we're talking about 45. So we're going to show you how we can use those. We can use this fact that sine of 45 is equal to this. Later on, to find the sine, cosine, and tangent. I can also find the cosine here to be what? Cosine is going to be the cosine of an angle is equal to adjacent over hypotenuse. So the cosine here of 45 will be adjacent, which is going to be the same thing, square root of 2 over 2. And now, if I use the relationship that tangent of an angle will be equal to opposite over adjacent, I will have 1 over 1. So the tangent of a 45 degree angle will be equal to what? 1. We'll use this concept to find other measures or other angles that are some multiples of 45. As we go on, we'll extend that concept. But remember, sine of 45 is 1, cosine of 45 degrees is 1, and the tangent of 45 degree angle is 1. No, sorry, the sine of 45 degrees is square root of 2 over 2, the cosine of 45 degree angle is square root of 2 over 2, and the tangent of 45 degree angle is 1. Let's go on to looking at how can we develop how to find the measure of a 30 degree angle, a 60 degree angle, the sine and cosine. So we look at this triangle, which we're going to say is a equilateral triangle. All sides are equal. All sides measure 2. Now if we bias, and then so because all sides are equal, each angle is going to be 60 degrees, 60 degrees. Now if we draw this to bisect this angle, we're going to end up with two 30 degrees angles here, correct? So, and then also we are cutting this piece into half, so it's going to be 1 and 1. So what we have is that we have something like this. This base here is going to be 1. This angle is going to be 90. Alright? The angle up here, like we said, we bisected it, so it's no longer 60. It's 60 divided by 2, 30. And then this base angle here will be what? 60 degrees. So now what we have is a 30, 60, 90 triangle. We can use this to find the sine, cosine, and tangent of 30 degree angles, 60 degree angles. And then we can apply this concept to other angles. So let's see how do we find the sine, cosine, and tangent of 30 degree angle. So let's go. Sine of 30 degrees angle. We said sine here is a 30 degree. It's going to be opposite, which is 1 over. Now, I forgot to find this. So let's do that quickly. Let me do that up here. So this is we can use the Pythagorean theorem. So I don't know this. Let me call this small b. So I can say b squared plus 1 squared is equal to c squared, yeah, which is going to be 2 squared. So what I have here is b squared plus 1 is equal to 4. Subtract 1 from both sides. B squared, 4 minus 1, I'm going to get what? 3. Take the square root, take the square root. B is equal to square root of 3. So this side here is square root of what? 3. So to find the sine is going to be 1 over the hypotenuse. So that's 1 over 2. So the sine of 30 degrees is 1 over 2. The cosine of 30 degrees is going to be equal to the adjacent, which is square root of 3 over 2, and then the tangent of a 30-degree angle. Tangent of 30-degree angle will be tangent of a 30-degree angle would be opposite, which is 1, over adjacent, which is square root of 3, and then we can rationalize multiplying denominator and numerator by square root of 3. So we're going to have the tangent of 30 degrees to be equal to square root of 3 over 3. Now let's try now to find the similar relationship for the 60-degree angle. So I'm having a 60-degree angle. I'm going to say sine or 60 degrees is equal to opposite, which in this case is square root of 3 over hypotenuse, which is 2. Cosine of 60 degrees is equal to the adjacent to this, the adjacent to the 60 degree, which is 1, over the hypotenuse, which is 2, and then the tangent of 60 degrees is equal to the opposite. Opposite 60 degree will be square root of 3 over the hypotenuse, over the adjacent, which is 1, so it's just going to be basically square root of 3. So basically we have all of these relationships: sine, cosine, tangent of a 30-degree angle, sine, cosine, and tangent of a 60-degree angle. Earlier we did sine, cosine, and tangent of 45 degrees angles. For a unit circle, what is a unit circle? A unit circle is a circle of the radius to be equal to what? 1. So all these radius will be equal to 1. So we can use the concept of a unit circle to find, and I'm going to be interested in what we call quadrant angles. Quadrant. Quadrant. I'm sorry. I'm going to be interested in just some of these quadrant angles, but I will also talk about other angles. Quadrant. So the quadrant angles are the angles that are on the axis here. For example, we're talking about 0 degrees. We're talking about 9 degrees. We're talking about 180 degrees. We're talking about 270. We're talking about 360 degrees. So, well, what we can do for them is to basically write the coordinates of those points. So, for here, the coordinate of this point here is 1, 0. The coordinate of this point here is 0, 1. The coordinate of this point is what? -1, 0. And over here is 0 for this point right here is 0, -1. We can find the sine of those angles. It's a basic relationship to do. The sine value of this angle is associated with the y. This is sine. This is going to be cosine. The same thing. Cosine and sine. We can go around. So basically, I can say that the sine of 0 degrees will be equal to what? 0. The cosine of 0 degrees is equal to 1. I can come and find the sine of 90 degrees will be equal to 1, and the cosine of 90 degrees will be equal to 0. I can also do it for here and say that, look, the sine of 180 degrees will equal to 0. The cosine of 180 degrees will equal to -1. And I can do it for this and say that, look, the sine of 270 will be equal to -1. Cosine of 270 will be equal to 270 will be equal to 0. Now, We could extend the values of the, we could do the same thing for 30, 60 by considering this angle we have here. So, and then we can proceed. This is a 30-degree angle. So the side opposite here will be 1. Over here is going to be square root of 3. And this is going to be 2. So the sine here will be 1 over that. The same thing we got in the last slide. So now, let's see how we can use this concept of unit circle with what we did earlier to find the measure of any angle of a triangle, to find the sine, cosine, and tangent of a 30, 60, 90-degree angles, or 180 and 270 without using a calculator or a table of values. So let's see how it works here. Now, first of all, sine of pi over 3. Let me go. This is something when I discussed the unit circle I did not talk a lot about, but let me talk about this. So here's a circle. So now I have divided circles into quadrants. Now, I can split, not that good, but from here to here is a pi. So I've divided this pi here into 6 parts. So each part is going to be pi over 6. This is another pi over 6. It's 2 pi over 6. This is 3 pi over 6. This is 4 pi over 6. 5 pi over 6. And this is 6 pi over 6. I can continue, but let me do something quickly so that you see it. 2 pi over 6 is the same as what? Simplified, it's going to be pi over what? 3. Now, what is pi over 3? What's the measure of pi over 3? So if this is 180 degrees, and I divided it into 6 equal parts, so each part is 30. So pi over 6 is going to be, so this pi over 6 is going to be a 60-degree angle. So how then can we find the measure of that angle? So what we want to do is to take it like this. So we know that that's a 60-degree angle right here. So how do I find the sine of it? Let me take that. So I'm going to do this. So this is a 60-degree angle. So all we have to do is a right triangle we form here. The side opposite 60 is going to be our square root of 3. The side adjacent to 60 is going to be 1. And this side is going to be, the hypotenuse is going to be the 2. So how do I find the sine of 60, which is the same as sine of pi over 3? It says it's going to be what? Opposite square root of what? 3 over the hypotenuse, which is what? 2. Simple and easy. So what did we do? We found the angle, and then we're able to sketch it and see how we do this. Good. Let's try another one. So we do not need a calculator for this. So again, this is a concept that we can do. We can try this. So in fact, let me. So one approach to doing this is to actually identify the location of this angle. And maybe, good. So where's 5 pi over 6? So this is pi over 6 if we divide this into equal parts. So 1, 2, 3, 4, 5 pi over 6 is right there. So let's see how we can draw that 5 pi over 6. Now, we have to take into consideration, so in fact, let me do this. So that 5 pi over 6 is an angle here like this. 5 pi over 6. If I change 5 pi over 6, you're going to find that it's 150 degrees. But how can we find it? The sine and cosine of the angle. We use the concept of what we call a reference angle over here. So what I do is that I will take 180 degrees because that angle is located in this quadrant and minus 150 from it, and I will get what? 30. So actually I'm dealing with this angle here being what? 30. So the side opposite it will be the shorter side. This side is going to be square root of 3, and this side is going to be 2. What am I finding in this problem? I'm finding the cosine. So the cosine of 5 pi over what? 6 is equal to the adjacent, which is square root of 3, over the hypotenuse, which is 2. But this angle is located in this quadrant. In this quadrant, this value here is a negative. So our sine here will be negative. So the cosine of 5 pi over 6 is basically negative square root of 3 over 2. Again, the location of the angle is very important. We're going to come back to discussing these videos here more in another section. Okay, let's look at another problem again. So here's my pi from here to here. So pi over 4 is meaning I'm dividing this pi into 4 parts. So this is pi over 4. This is 2 pi over 4. When I simplify this, I'm going to have just pi over 2. This is 3 pi over 4. And this is what? 5 pi over 4. This was going to be 4 pi over 4. This is 6 pi over 4. And this is 7 pi over 4. Now, basically, so if we check, each one of these angles is 45, 45. So 7 pi over 4 is an angle that comes out of the 45 degree angle. So we know that the sine and cosine of any angle of that nature is either going to be square root of 2 over 2 or negative square root of 2 over 2. So all we need to do is to locate the sine or cosine of that in the tangent. So where is this angle located? It's located in the fourth quadrant. And in this quadrant, you have positive this way and negative this way. So you have positive and negative. So the tangent is going to be negative. So remember, anything that has to do with pi over 4, the tangent has to be negative. So because the tangent has to be 1. Where's this angle located? It's located over here. In this quadrant, the tangent is negative. So our answer is going to just be what? Negative 1. Simple, easy. Production of the Foundation Equity and Excellence in Education in Liberia, a foundation dedicated to providing quality content education for all Liberian children. We are located at www.feedliberia.org on the web. We are also on Facebook. Follow us on, like us on Facebook. Follow us on Twitter. Don't forget to subscribe to our YouTube channel so that as soon as we produce new videos, you can have access to those videos. Also, it's important that you make your contribution. Any contribution you make will help us improve the quality of our product and to expand our services to other content areas. Again, thank you.